Hello everyone and welcome to the lesson number 38. Today we will be talking about Linux networking and about the TCP IP. It is a theoretical lesson. The TCP IP is a protocol that is used for network communications. The TCP is the transmission control protocol that controls the data exchange. The IP is the Internet Protocol, and it is responsible when a device sends data to another device. When you say hosts in networking and in IT, you mean the devices on the network that have an IP address. About the IP networking, in order for the devices in the Internet to communicate properly, each one needs an address, like the address you have for your own house, for example. If someone wants to send a letter to you, then he needs to have this address. An example of an IP address would be 198.55.120.164. And if you want a live example, then you can open up your terminal, type IP address, and then here you can see your own IP address. For example, my own IP private address here would be the 192.168.1.88. Every IP address has a subnet mask. For example, 255.255.255.0, and it is also possible for you to show this address like /8, /16, /24, or / any other bits. For example, /24 means that the first part of the address, the network address, the network part, has 24 bits turned to 1. We'll see about it. So there is also a broadcast address, for example 198.55.120.255. This is the last address of this subnet, and it is a special address because it sends a message to all the hosts of the network, and it can be used from a normal host as an IP address. So if we want the available addresses, we start from the first address until one address before the broadcast address. And the form is the following: octet, 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 octet. I assume that you already know what an octet is. And as I stated before, an IP address has two parts. The first part is the network address, and the second part is the host address. The network address tells the routers in which network the host belongs to. The second part, the host address, tells the routers the specific address the message should be delivered to. The class of an address determines which portion of the address is used for the network part and which for the host part. The first octet is this, for example, the 192 in our example, shows us in which class this address is. There are not only 3 classes, but the main classes that you should know for this lesson, for the Linux networking, would be the 3 first classes: the A class, the class A, in which belong the networks from 1.0 to 127.0, and the hosts that are allowed there. There are 16 million hosts, almost 17 million. An example address would be the 12.25.70.4, And the subnet mask for the class A network would be the 255.0.0.0/8. This /8 indicates that the network pack, the network part here is full and the other parts are 0. If we want to demonstrate it with bits, this would be an octet is 8 bits, which are either 1 or 0. And if it is 255, it means that we have 8 times 1 bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. And this would be the first octet. If you have 255, then you have 8 bits that are turned to 1. And then if you see the 0, then the next octet, the second octet, would be 1, 2, 3, 4, 5, 6, 7, 8. 8 bits that are turned to 0. And the third octet would be exactly the same, like that. And the fourth octet would be also exactly the same. And now this is an example of a /8 network IP address subnet mask, because if you can see, if we see the number of the ones is 8. 1, 2, 3, 4, 5, 6, 7, 8. If the address would be /16, let's see it here, this would mean that the number of the ones would be no, it didn't work. That would mean that the number of ones in the second octet are 8. So you have overall 16 times the bit 1. And if you want to write it as a subnet mask, then you would write 255.255.0.0. And if your subnet mask is /n24, then you have 24 times the bit 1. So you need 1, 2, 3, 4, 5, 6, 7, 8. And this would be the /24 subnet mask. So let's go back to our classes. The class B is the network from 128.0 until the 191.255, and the hosts that are allowed here are 65,536. So there is a formula, a mathematical formula to do that, but you don't mind the formula at this moment. Anyone who wants to learn a little further of that, you can send me a private message, or you can search in Google, because at this time there are many online tools, or also not online tools, that provide you the IP addresses and the hosts, and you don't need to do the calculations on your own. So here's an example address, the subnet mask, and as we said, the class C is in this range here. As you can see, the host that are allowed is the 255, and this is an example address, and the subnet mask is exactly as we stated here. An example would be this kind of address, 199, 32, 154, 22, and if it has a subnet mask of 255 3 times and then the 0, it would mean that we work with this octet with the fourth octet. So what is the CIDR? It is a classless interdomain routing, and it allows networks to be subdivided regardless of their traditional class. The addresses created are called subnets, and that way you don't waste any too many addresses which remain unused. For example, if you have the address 148, 55, 162, the class A network would be this one, 148, and then you will put everything to 0. Why would you do that? Because when we say a class A address, the subnet would be the 255.0.0.0. So it means that we work with the first octet, and all other octets are 0. And the broadcast would be, we will take the first, the 148, and then we would put 255 to all other octets, and this would be our broadcast address. So here we have too many addresses that we waste if we have a network of, for example, 10 computers. If we need only to give 10 IP addresses, and we have millions of available of addresses, they are all wasted. So what we can do is to subnet these IP addresses. And an example would be, we will take this address and we want a subnet of /24. And why would we want this kind of subnet? We'd like this subnet because if you can see here, the hosts that are allowed here are 255, so we don't waste that many hosts. But in a class A, as it was, you have 16 million addresses that are available. So if you just want 20 or 100 addresses, IP addresses, the rest are being wasted. So the CIDR network, if we want a /24, would be this one, because you take the original address and you see the subnet at the subnet where you see the 0 is at the last octet. Then we put a 0 at the last octet, and this is the network address, the first one. So the subnet is, as we stated, /24, and the broadcast, it's easy. You just take this octet that you use and you turn it to 255, and the available addresses, if you want the range that you can use in this network, would be the 148, 55, 101. You always begin, you can always use the next address of the network address, because you need this one for the network. So if we want the address, the available address, IP address range, then we take the network and we begin from the first one, and we go until the broadcast, but without this one. So we go one IP address before the broadcast address, and this is our range. And you don't waste 16 million addresses anymore. You just wait. Maximum waste would be 200 addresses, 250 addresses or so. You can also use another slash, a lower slash, and then you can save. You can use exactly the number of the addresses that you need to. And the last part is the dedicated addresses for private networks, because we all have a private network in our house, which is the network that is connected to our router. So, for example, if you have your networks, your telephones, your mobile telephones connected to the Wi-Fi, they take an address from this private sphere. If you have your laptop connected to the Wi-Fi or with a cable, it also shares these private addresses and the desktop PCs and so on. And the range would be, if it is a class A, this would be the range from the whole class A, and the private addresses, which were defined in the RFC 1918, are from 10.0.0.0 to 10.255, 255, 255. And if we talk about the class B address, then this is the range, and the private sphere would be these addresses. And the smallest network, the class is C, this is the range, and the private addresses are inside this range. And this is why most of the time when you have a home network, the IP addresses that you have are similar to this one inside this range. And as you can see, at this moment this machine has been given this IP address here, which is inside this private sphere. So enough with the theory. If you have any questions, just let me know, and thank you all for watching. See you to the next lesson.